Hi everyone, welcome to part C of the quiz. Part C of quiz 1 revision. Okay, so the question is saying let alpha and beta be the roots of the equations. Of the equation 2 plus 5x minus 3x squared being equal to 0. Without solving the equation, find the value of alpha over beta plus beta over alpha. So the first thing that you need to understand when you see such questions, the first thing that you need to know is to find alpha. What is alpha plus beta? Whenever you're solving such a question, these are very important. You write them somewhere before you start writing. Actually, you put them on the paper. So alpha plus beta is just found by negative b over a. So negative b will be negative 5 over our a there is just a coefficient of x squared, which is negative 3. So meaning our negative b over 5, over a is just 5 over 3. Then we also find what alpha times beta is. So alpha times beta is just equal to c over a. And then this is going to be c. So our c is just 2, and then our a is just negative 3. So this is just going to give us negative 2 over 3. So after finding this, we can now, after finding these two important things, we can now go on to solving the equation. So they are asking us to say we find alpha over beta and then plus beta over alpha. So here what you do, you first find the common denominator as usual. Then when you divide there, you get alpha squared plus beta squared. So when you find alpha squared plus beta squared, then over alpha times beta. So we already have alpha times beta, but we don't have alpha squared plus beta squared. So we need to find that. How do you find alpha squared plus beta squared? So alpha squared plus beta squared is just given by alpha plus beta, then squared minus 2 alpha beta, then everything divided by alpha beta. So you can prove this by finding this. Or how did I come to this alpha plus beta squared minus 2 alpha beta? Simple. You just find you just say, what can I get if I say alpha plus beta squared? So you are when you do as this, you expand this, you are going to have this alpha squared plus 2 alpha beta, and then plus beta squared. So you just put alpha squared and beta squared together, so you have something like this: alpha squared plus beta squared, and then you say plus 2 alpha beta. Then this side you have the same thing, which is alpha plus beta, then in brackets squared. So here what you do is that you just leave this part, this side, and then you take this 2 alpha beta to the other side of the equal sign. So you just have alpha squared plus beta squared being equal to, it's going to be like this. You take this to the other side of the equal sign. So I'll write this: alpha plus beta, then squared minus 2 alpha beta. Okay, so this is where I got it from, and then I wrote it there. So from there, this is now simple. What you do is, while there is alpha plus beta, you just put this value. While there is alpha times beta, you put that value. So while there is alpha times beta there, you put that value. While there is alpha plus beta, you put that value. Even on the denominator, you do the same. So this is how you solve such a question. Let us quickly move on to the next question. So our next question is saying an equation whose roots are 1 over alpha and 1 over beta. So when we talk about roots, roots are just the answers that you get after solving a quadratic equation or after solving an equation. So x is equal to 1 over alpha. Another root that we have is x is equal to 1 over beta. So what you do now is you just take this to the other side of the equal sign. Same applies to this. You take it to the other side of the equal sign. So what you do is you just take this to the other side of the equal sign. This is what you have. So this side you just remain with a 0. Then again this side will be 1 over beta is equal to 0. So from there you can agree with me that what we are doing here is just the opposite of factorization method of a quadratic equation. So this is what you are going to do. Put them in brackets, then equate everything to 0. So here you just multiply x times x, you get x squared. X times negative 1 over beta, you get 1 over beta, then x, then negative 1 over alpha times x, you get negative 1 over alpha x, and then negative 1 over alpha times negative 1 over beta, you get 1 over alpha beta, and then this is all equated to 0. So from there you are going to have x squared, then minus, in brackets you have 1 over beta plus 1 over alpha, and then your x will just be written outside. Then you write something like this, being equal to 0. So this is what you are going to have. Then on top there you are going to have alpha plus beta. So there, what you do on this part, you just simplify it, you change it, you make it as a single fraction. So this is how it's going to be, being equal to 0. So from here you can see that it's now even easier for us to find the equation, because we know what alpha plus beta is, we know what alpha times beta is. Even here we know what alpha times beta is. How do we get those things? We know to say alpha plus beta is just equal to negative b over a, and then we know to say alpha plus beta, alpha times beta is just equal to c over a. Alright, so you get them from this equation, c over a, so it will be 2 over negative 3, and then negative b over a will be 5 over 2. Yeah, so you find them and then come and replace them while there is alpha plus beta and alpha times beta, and then simplify the expression. Whatever that you are going to get is going to be a solution. So we'll quickly move on to the next question. So the next question is saying let f of x be equal to 2x squared minus x minus 6. The first question is telling us to express f in the form that, and then hence determine the turning point. So the first question is f of x is equal to that, is equal to 2x squared minus x minus 6. So here what you do is you factor out the 2. So you factorize the 2. So once you factorize the 2, you are going to have something like this, minus 1 over 2 x, and then you close the brackets, minus 6, and then from there you're going to have these two outside, and then open brackets. You complete the square of these of what is in the square brackets there. So meaning you're going to have x squared. Wait. So you're going to have x squared, then minus. Sorry, you say plus. You find half of this, so it's going to be 1 over 4. It's going to be 1 over 4, and then of course it's going to be a negative, because half of negative half is negative 1 over 4, and then you square this, and then you say minus the same thing, negative 1 over 4, and then you square it, minus 6. So you put them in brackets there. So if you want, you can also add this minus 1 over 2x in brackets. You say minus 1 over 2x in brackets if you want, but if you don't want, you can leave it, there's no problem, unless maybe the marker is just too strict when marking. So we quickly move to the next question. So we're going to now, sorry, not next question, but the next step. So we're going to now complete the square. We're going to say x. You get the sign of what is in the brackets there. So it's minus 1 over 4, minus 1 over 4, and then brackets like that, squared, and then minus 1 over 16, and then minus, so you put it in brackets like that, and then you say minus 6. So you now multiply 2 times x minus 1 over 4 squared, and then this will be 2 times 1 over 16 will be negative 1 over 8 minus 6. So when you add these two, this is going to give you 1 over 8 minus, plus 6 will be. So when you add these two, you get negative 49 over 8. You get negative 49 over 8. So this is basically what they wanted you to do by this question. Yeah, in this question they wanted you to do this. So this question is done. We move on to this part, which is saying determine the turning point. So how do you find the turning point? So the value of x at the turning point, is just found by equating x minus 1 over 4 to 0. So you say x minus 1 over 4 is equal to 0. Make x the subject of the formula is going to be 1 over 4. So meaning the value of x is 1 over 4. So to find x at the turning point, you just equate here what is in the brackets there to 0. Then you say comma this 49 over 8. 49 over 8. So this is basically the turning point. And then you move on to the next question. The next question, which is the second part of the question, which is saying sketch the graph of that showing all the intercepts. So the y-intercept is just, let me first start by finding the y-intercept. So the y-intercept is just y is equal to negative 6. This is the y-intercept. Why do I say negative 6? In other words, you are just going to find f of 0 here. You put 0 there. So meaning wherever there is x there, you put 0, you put 0. Then you simplify the expression, you get negative 6. So this is the y-intercept. You get negative 6. So to find the x-intercepts, you just equate the given expression, the answer that you have found, this one, to 0. So you equate 2x minus 1 over 4 squared minus 49. So minus 49 over 8, you equate this to 0. So when you equate this to 0, you take this to the other side of the equal sign. 49 over 8, when you take it to the other side of the equal sign, you're just going to have something like this. It will change to be from negative 49 to be positive 49. Then divide by 2, even this side divide by 2. So this 2 and that 2 cancel. 2 into that, then it's going to be 49 over 16. So it's going to be 49 over 16. So after doing this, we get rid of this square now. How? By squaring the by squaring both sides. But remember, this side, it always moves with plus or minus. So meaning we're going to have our solution to be x minus 1 over 4, and then is equal to plus or minus the square root of 49 is 7, the square root of 16 is 4. So you just take this 1 over 4 to the other side of the equal sign. So meaning you're going to have 1 over 4 and then plus or minus 7 over 4. So 1 over 4, so the first value of x, we're finding the x-intercepts. The first value of x will be 1 over 4 plus 1 over 4 plus 7 over 4, which gives you 8 over 4, which is just 2. The other value of x that we're going to find is 1 over 4 minus that, so meaning it's going to give us, it's 1 over 4 minus 7 over 4. So minus 7 over 4. So this is going to give you negative 6 over 4, which is just the same as 3 over 2. Negative 3 over 2. So these are the x-intercepts that we have been asked to find, and then the y-intercept is just y is equal to negative 6. So now we sketch the graph. So it's meeting the x-axis at this negative 3 over 2 and at positive 2. So this is what we're going to do. And then you have to also know whether it's minimum or maximum. How? By looking at the coefficient of x squared. So since the coefficient of x squared is positive, then we know to say it's minimum. So our turning point is 1 over 4 comma negative, sorry, this is supposed to be a negative here. You get everything this side. So negative 49 over 8, negative 49 over 8, that one is just the same as, so it's just the same as 6 over 1, 1 over 4, which is 6.125. So I'll just put it here. I'm just sketching, so I'll write my negative 49 over 8 there, and then I'll write my 1 over 4 there. So meaning my turning point will be somewhere there, and then we'll sketch it this way since we know that it's minimum. So this is how it's going to come out. So you name this point is 2, and then we have this other point, the other x-intercept we had was 3 over 2, and then what else? The y-intercept is negative 6. So the y-intercept is the point where it cuts the y-axis, and then the x-intercept is just the point where it cuts the x-axis. So you also label all your, what's this, like that. Alright, so this is basically how you solve such a question. So I've solved everything just here, and I've explained it very clearly. So we quickly move on to the next question. So the next question is saying, if the sum of the roots of the quadratic equation that is equal to twice its products, find the values of k, hence determine its roots for the values of k. So if the sum of the quadratic equation, if the sum of the roots of this quadratic equation, so meaning they are telling us to say if the sum of the roots, so if our roots are alpha and beta, if the sum of these two roots, alpha and beta, is just equal to the product of its roots. So meaning it's equal to 2 is twice the product of its roots. The sum is twice the product of its root. So meaning it's 2 times the product. Yes, so the sum is 2 times the product of its roots. So meaning this is what you are going to get from just the from the first statement there. You get this expression, and then they are telling us to say hence determine its roots for the values of k. So what you do here is simple. You have about 2 ways in which you can solve this question. So first of all, you find what the sum is. The sum alpha plus beta is given by, so alpha plus beta is given by it's given by negative b over a. So my b is negative 1 plus k. So my negative b will just be 1 plus k, since 1 plus k is already negative there. When you multiply negative and negative, you get a positive. So, and then my a is simply just k. And then I also find the product of these 2 roots. So my product is just found by c over a. C over a. So what is c? My c is simply 3k plus 2, and then over my a is simply k. And then we move on now to solving. So now we replace what we have found here into that expression. So where there is alpha plus beta, we put 1 plus, where there is alpha plus beta, we put 1 plus k. Then where there is 1 plus k over k, then where there is alpha times beta, we put 3k plus 2 over k. So just from this expression here, you can see that this k and that k are cancelling. So if you want, you can what's this, you can prove it. Okay, so if you want, you can prove it. Yes, so you are going to say 2 times everything there. Let me just say this: k 1 plus k is equal to 6k plus 2, 6k plus 2, 6k plus, oh sorry, plus 4, not 2. So this k, when you multiply it with that, and this when you multiply it with that, divide by k both sides, you still do as this, you still come back to this expression. So you are going to have this one go to the other, this k go to the other side of the equal sign, meaning you are going to have 5k being equal to this 4. When it goes to the other side of the equal sign, you are going to have negative 3, because it's going to be 1 minus 4, which is negative 3. Divide by 5, divide by 5. So meaning the value of k that we have is simply just negative 3 over 5. Then from there, we now just replace it there, and then we've been told to determine those roots. So we replace the value of k there. We're going to have negative 3 over 5 x squared, then minus, and then minus, we say 1 positive k, we have a negative there, so we say 1 minus 3 over 5 x, then we have plus 3, while there is k, we put negative 3 over 5, and then plus 2 is equal to 0. So here we have Yeah, but if you want to simplify this properly, we can first multiply all the equation, the whole equation by 5, so that we get rid of the denominators, we get rid of the fractions. So we multiply all the equation by 5. So we multiply negative 3 over 5 times 5 there, you just remain with negative 3 x squared, then minus, so this is just going to be we'll say 5 minus 3, yes, and then we have x outside, and then we say plus 3, there we have negative 3, so we're multiplying all the terms by 5, then there we have 10 being equal to 0. So we are going to have negative 3x squared minus 5 minus 3, you get 2x, then you say I don't know if it's going to give us a plus or a minus. First let's work it out. So we work it out first. So we're going to have negative 9 plus 10. Negative 9 plus 10, you just get a positive 1 there. So here it's just a matter of us finding the roots, finding now the roots. So how do we find the roots? We find the product and the sum. So the product and the sum, the product is negative 3, you multiply negative 3 times 1, the sum is simply negative 2, and then the factors now will just be equal to, so the numbers that we can multiply to give us negative 3, when we add them to give us 2, so already I know to say it's 1 and 3, but which one should I give the negative? Because I know that the sum is negative, so meaning I will give the bigger number a negative. So we proceed now by factorizing. So we're going to have 3x squared minus, or we start with a small number, which is minus x, and then it's a positive 1, meaning plus x, then minus 3x, and then plus 1 being equal to 0. So from there we just factor out what is common there. We have negative x is common, so every time when the negative is in front there, just factor it out, it's always common. So we have negative x is common, so we have x minus 1 there, 3x minus 1 in brackets, then here again the negative is starting, so meaning it's common, negative 1, so we have 3x plus to be a minus 1 is equal to 0. And every time you're solving a quadratic equation, if you find whatever that is in the brackets to be different, then you are wrong at some point, so meaning you have to revisit your question. So you're going to have 3x minus 1 in brackets, and then you also have negative x minus 1 in brackets again. So this is what you're going to have. So when this crosses the equal sign, you have x to be equal to 1 over 3, and then the other x will just be equal to, so the other x will just be equal to x will just be equal to negative 1. Now here you need to test one thing. Oh, sorry. Anyway, I can remember, I've just accidentally erased everything. So the first value of x we found was 1 over 3. Then the second value of x that we found is what's this, is I think negative 1. So we need to test something here. You can try it out to see if you are getting the if what we are given is what's this? Okay, so if it's agreeing with what's this, the conditions that we are given, so they told us to say the sum, meaning when you add this 1 over 3 plus 1, so this, according to our expression there, is telling us to say it's just the same as 2 times the product of that. So the product of that, so these are square brackets, so you can say 1 minus 3, this is just the same as negative 2 over 3, and then you also check this side if you are getting the same answer. So negative 1 over 3 times 2, we just get negative 2 over 3. We can see that this is agreeing with our solutions, meaning what we have solved is correct. This is how you prove such questions. So we move on to the last question. I think this is the last question, yes. So we move on to the last. She's saying the function g is defined by that, and then it's also telling us, so I've decided to solve this question at the end because of this question. It's I would say maybe cumbersome because it's long, it has a long procedure. So we move on to this question. So it's saying evaluate g of negative 5. So g of negative 5, you look at the functions that you have been given here. Negative 5, in which range does negative 5 fall? In which range is negative 5 falling? Of course, when you look at this function that you've been given, it's falling below negative 2. We know to say negative 5 is less than negative 2. So if negative 5 is less than negative 2, then the function that we are going to use for g of x is just going to be the first function there. So the first function there is negative 2, and then our value of x has been raised to power 0 because we don't have any value of x there, so you just raise it to power 0. So you are going to have something like this, where there is x, you put negative 5, then you raise it to power 0. Any number raised to power 0 is equal to 1, so we're going to have something like this. As a result, we just go back to the same negative 2. So this is done, the first part is done. Move on to the second part. The second part is saying for x being a member of this, meaning this is the interval that we've been given, meaning this is just the same as this part here. There's no difference. So in this interval, is g a one-to-one function, hence or otherwise determine g inverse of x. Yeah, the time I was solving this on papers, I never saw to say there was this question. Alright, so we say in for this expression there, is g a one-to-one function? How do you determine if this is a one-to-one function? You find f of a and also find f of b. So from that interval, f of a will just be equal to a minus 1 over b plus, a plus 1. A plus 1, that is a plus 1. So this is this for for a function to be a one-to-one function, f of a is always supposed to be equal to f of b, which implies that a should always be equal to b. This is what is supposed to be what's this? This is what we're supposed to get. Or in other words, if you want, you can just find f of a and then you also find another f of a and then you equate them, still the same. So we find f of a, we also find f of b. So f of b will just be equal to b minus 1 over b plus 1, which is just the same as f of b. So what you do here, you cross multiply. So once you cross multiply, you simplify the expressions there. You discover that the answers that you get after simplifying, you just find yourself to this point, a is equal to b, which implies that it's a one-to-one function. And then it's going further to tell us to say hence or otherwise determine g inverse of x. How do you find g inverse of x of this function? So g of x has been given. So g of x has been given to be equal to x minus 1 over x plus 1. So to find g inverse of x, you first have to equate this part to 0. Sorry, not to 0, equate it to y. So you say let y be equal to that. So let y be equal to x minus 1 over x plus 1. So from there you cross multiply, meaning you are going to have something like this, x minus 1 being equal to x times y. There you get xy, y times 1, you get y. So here we are trying to make x the subject, meaning we'll take this negative 1 to the other side of the equal sign, and then this term which has x in it, will bring it to this other side of the equal sign. So meaning we're going to have something like this, xy will come here, and then we'll have y plus 1, like that. And then you say x, open brackets, 1 minus y, close brackets, being equal to y plus 1. Then you divide by x, you divide by, oh sorry, not dividing by x, but dividing by 1 minus y. You divide by 1 minus y. Even this side you divide by 1 minus y. So after dividing this, you can see that this and that are cancelling, so meaning we're just remaining with x being equal to y plus 1 and 1 minus y. So the function g inverse of x will now just be equal to, while there is y there, we just put x plus 1 over 1 minus x. So this is the function g inverse of x. Alright, so this is how simple these questions are. Let's quickly move on to the next question. The next question is saying find the values of x in the interval 2x to the infinity, meaning what they're trying to talk about is this interval there. So meaning we're going to look at this. They're saying find the values of x in this interval for which g of x is, g of x minus the root of x plus 7 is equal to 2. So in other ways, while there's g of x, we are going to replace with that functions there. So how do you do that now? So you say 2x minus 3, while there is g of x here, we put this function. This is in the square root symbol, and then say minus the root of x plus 7 being equal to 2. Okay, so here you can now, if you want, you can first okay, the best way you can do this, you first take 1 to the other side of the equal sign. I think that way it's easier. You take one of these sides to the other side of the equal sign, so meaning you are just going to have something like this. Let me just, looking at space here, so I'll just say this equal sign will come here, and then it's going to be like this. Okay, it's going to be like this, to be a positive to this side, and then since this one has crossed the equal sign, to be a positive like that as well. Okay, so now here's just a matter of squaring both sides. We square both sides. So when you square this side, we're going to have 2x minus 3 being equal to, when you square this side, you're going to have 4 root x plus 7, then you are going to have plus x plus 7 plus 4. So what I've done is just basically multiplying this times itself. It's giving me this times 2, it will give me 2 root x plus 7, and then again this root x plus 7 times 2 to give me the same thing. So when I added the 2, I got 4 root x plus 7, and then 2 times 2 will give me 4. So 2x minus 3, I will just now simplify the expression. So 2x, when this x, so 2x minus this x, when it crosses the equal sign, we're going to have x this side, then we'll have 7 plus 4. So 7 plus 4 will give us 11, and then 11, when it crosses the equal sign, is going to be I think it's going to be negative 3 minus 11 is going to be negative 14. So this side will remain with 4 root x plus 7. So here again we do the same. We square this side. We also square this side. So when we square this side, we are going to get something like this: x minus 28 x, and then this will be x squared minus 28 x, and then 14 times 14, there you get something like 196. So this will be plus 196, and then this is equal to 4. When you square this part, you're going to have 16, and then this, you put them in brackets, you have x plus 7. So here it's just a matter of pairing the like terms again. So you have x squared minus 28x, and then we have 28x minus 16x, and then plus 196 minus, we have 16 times 7 there. 16 times 7 gives you 112. So 196 minus 112, everything is equal to 0. So the expression that will be requested to solve is just going to be equal to, so 28, negative 28 minus 16 gives you 44. So this is the expression that will be requested to solve, and then you have something like this: 196 minus 112. 196 minus 112. So 196 minus 112 gives you 84. So this will give you 84 plus 84. So you guys, I'm sure you can't fail to solve a quadratic equation. I've solved a lot of questions here which are quadratic equations. You can find the product and the sum. If that formula fails, use the formula method. If that fails, use completing the square method, which is just almost the same as the formula method. So you can solve these quadratic equation, this one here, in order to find the values of x which they are looking for. Alright, so thank you very much for watching today's revision for quiz 1. Make sure that you subscribe to the channel if you've never subscribed to the channel. If you have not subscribed to the channel, subscribe so that you don't miss out the videos that I'm going to be posting. Alright, and then for those guys, alright, let me not say this. See you in the next tutorial video. Shalom.